Hello. All right. So in the previous video, we started section 7.2, sum and difference identities in sine and cosine and trig functions. In this video, we are continuing to work on different examples, okay? All right, let's look at this example. Use a sum or difference identity for cosine or sine, actually. This is asking sine, right? Maybe I should better cross this and say sine to evaluate sine 7 pi over 12 exactly. Again, sine 7 pi over 12 itself is not a spatial angle because there is no spatial triangle for this angle, right? But we can rewrite this angle sum of two spatial triangle angles, okay? And we can use the formulas to find the answer. But before doing that, 7 pi over 12, let's convert it to the degrees, okay? It's easier to work with degrees. So 7 pi over 12 times 1/8 over pi. I cross out pi's, and I can simplify 180 and 12, which is given 15. 7 times 15 is 105 degrees, right? Okay, so we need to find what the sine of 105, and 105 is, as we did in the previous video, is equal to 45 plus 60, right? And we know what 45, we know the trig values for what trig values for 45 and trig values for 60, so we can find sine of 105. All right, so let's do it. Sine of 105 is equal to, and again, and I'm not putting degrees, but we know there is a degrees, and these angles are in degrees. That's equal to sine of 45 plus 60. And okay, what is the sum formula for sine? You always start with sine of 45 and switch to function cosine of 60. And if there's a plus sign, there's also plus sign here. And then again start with sine, but this time switch the angle. Sine 60 times cosine 45. And we already know what these guys are, right? Sine 45 and cosine 60, sine 60 and cosine 45. We did that in the previous video. Maybe I can show you quickly what they are. So, yes, here. Sine 45 is 1 over root 2, cosine 45 is again 1 over root 2. Sine 60 is root 3 over 2, and cosine 60 is 1 over 2. Okay, so sine 45 is 1 over root 2. Cosine 60 is root 3 over 2. No. So cosine 60 is 1 over 2. Plus sine 60 is root 3 over 2. And cosine 45 is 1 over root 2. So again, if I multiply the fractions, they will have the common denominator, right? So 1 plus root 3 over 2 root 2. And this is the this is sine of 105 degrees, and it's a positive value, right? And it makes sense because 105 is in the second quadrant and sine is positive in the second quadrant. Okay. All right, let's continue to the next example. Write sine x, sine 2x minus cosine x, cosine 2x as a single expression. When I look at this expression, it reminds us the sum formula for cosine, right? Cosine of a plus b. Let me remind you that formula quickly. Cosine of a plus b is equal to, if it is cosine, right, you just, in the first part, you just take cosine and cosine, right? Cosine a, cosine b. If it is plus here, it should be minus here. Sine a, sine b, okay? But only problem here is, right, normally I have to have a plus here and minus in front of signs, but here there is positive here and this is negative. So first of all, let me factor out negative there, okay? So let me write that down first of all. Sine 2x, sine x, sine 2x minus cosine x, cosine 2x. Let me factor out minus, okay? Cosine x, cosine 2x minus sine x, sine 2x. Cool. Now it's exactly in our form, right? And a is x, b is x, b is 2x. So let me use this formula then. So this is actually equal to minus cosine of, right, x plus 2x. So x is equal to minus cosine of 3x. Okay. So I just express all these expression as a single expression this way. All right. I hope it is clear for everyone. Let's continue. Maybe I can show you one more time. Yeah, this is how it is. So now let's look at the formula for tangent. What is the sum and difference formula for tangent? Tangent a plus b is equal to, if it is plus b, it is plus on the bottom and minus on the top. Sorry, plus on the top and minus on the bottom, okay? So tangent a plus b is equal to tangent a plus tangent b divided by 1 minus tangent a, tangent b. And if it is minus inside tangent, tangent a minus b is equal to tangent a minus tangent b over 1 plus tangent a tangent b, okay? All right, these are the identities we need to use. Let's look at this example. Use a sum or difference identity for tangent to evaluate tangent 165. Exactly. Okay, first of all, 165 is not a spatial angle, right? I mean, we don't have a spatial triangle for this angle. So I have to rewrite this as a sum or difference of two spatial triangles angle. And it's not always easy to see that. But for example, okay, I realized that 165 is equal to 165 degrees is equal to 210 degrees minus 45 degrees, right? And 210 and 45 are the angles of a spatial triangle. Okay, so I can use this difference. I hope I hope also you see how I got 165. Okay, I am not making a mistake, right? Yeah, I'm not making it. This is correct. Okay, so now tangent 160. Okay, 165 degrees is equal to tangent of 210 minus 45. And again, I'm not putting degrees because it is clearly in terms of degrees. That's equal to, and I'm going to use the second formula, right? So if it is minus here, it should be minus here as well. Tangent 210 minus tangent 45 divided by 1. And if it is minus, it is minus on the top and plus on the bottom. 1 plus tangent 210 times tangent 45. Okay. Now I need to find what tangent 45 and what tangent 210, right? So let me try to find where is 210. So 210 is here, right? And this angle will be 30 to make 210. So what are these sides then? Okay, first of all, this is negative x-axis, this is negative y-axis, right? So sides will be negative. So it is negative 1 here, negative root 3 here. Right, this is our spatial triangle. Let me also include 60 here. And hypotenuse is always positive, so it is 2. Okay? So tangent 210, so tangent of this angle is, tangent is opposite over adjacent, right? So 1 over root 3. Okay, so that's equal to 1 over root 3 minus tangent 45. Remember 45, 45, 90 triangle, right? It is if the tangent is opposite over adjacent, so it's 1 over 1. 1 over 1. It's 1 actually. 1 plus tangent to 10, so 1 over root 3 times 1 over 1. Okay. So, what it is equal to? Let's try to simplify that guy. First of all, let's try to have the common denominator. Let's multiply here top and bottom with root 3 over root 3. So we get 1 minus root 3 over root 3 here, divided by. And again, we have to have the common denominator on the bottom as well. So let's multiply root 3 over root 3 here. So it is root 3 coming from this part plus 1 coming from this part, right? Divided by root 3. And I can simplify root 3. So I'm on left with 1 minus root 3 divided by root 3 plus 1. So tangent 165 is 1 minus root 3 over root 3 plus 1. And as you see here, this is a negative value, right? Because 1 minus root 3 is negative. Bottom part is positive, so this is a negative number. And it's as expected because 165 is in second quadrant, and in second quadrant tangent is negative, right? Okay, great. All right, for this video, let me stop here. In the next video, I will continue working on more examples, and I'm gonna also give you the formula for cotangent. Okay, so for now,